Recall that when y equals f of x and it is defined over the interval between a and b, and this function is differentiable over that interval, the length of the curve is given by the formula integral from a to b of the square root 1 plus f prime of x squared. And let's apply this formula to find the length of the curve y equals f of x equals to inverse sine of x plus the square root of 1 minus x squared, defined over the interval 0 to 1. So first we're going to differentiate this function. The derivative of inverse sine is 1 divided by square root of 1 minus x squared. The derivative of square root of 1 minus x squared, since it's 1 minus x squared to the 1/2, is as follows. It's plus 1/2 1 minus x squared with a new power of minus 1/2 times the derivative of 1 minus x squared, which is minus 2x. Now we want to simplify this. So this will be 1 divided by square root of 1 minus x squared, and then minus 2 times 1/2 is minus 1, and then we have x, so this is minus x divided by the square root of 1 minus x squared. Notice that both denominators are the same, so we can combine the numerator and have single denominator. Therefore f prime of x equals 1 minus x divided by the square root of 1 minus x squared. Now we square the derivative. F prime of x squared is equal to 1 minus x quantity squared, and the denominator, squaring the square root, is going to give us 1 minus x squared, and we can write this as 1 minus 2x plus x squared divided by 1 minus x squared. Now we need to add 1 to the derivative squared. 1 plus f prime of x squared. Since the denominator of f prime of x squared is 1 minus x squared, we can write 1 as 1 minus x squared divided by 1 minus x squared plus 1 minus 2x plus x squared divided by 1 minus x squared. So this is 1 plus 1, that gives us 2 minus 2x, and then minus x squared plus x squared, that's 0, divided by 1 minus x squared. Now this is equal to, further simplifying, we can factor a 2. This is 2 times 1 minus x, and the denominator 1 minus x times 1 plus x. Canceling 1 minus x, we end up with 2 divided by 1 plus x as 1 plus f prime of x quantity squared. That's what we have to integrate. Therefore, the length of this curve is going to be the integral from 0 to 1 of the square root of 2 divided by 1 plus x. And let's simplify this. First, we take square root of 2. It's a constant. It can come out in front of the integral, times the integral 0 to 1, 1 plus x to the minus 1/2 power. And this is easily integrable. We can make substitution, or since u equals 1 plus x, du will equal to dx. This is just like u. So this is equal to square root of 2 times 1 plus x to the 1/2 power divided by 1/2 power evaluated from 0 to 1. Or we can rewrite this as 2 times square root of 2 times 1 plus x to the 1/2 power evaluated from 0 to 1. And let's plug in 1 first. 1 plus 1 is 2. 2 to the 1/2 is square root of 2. So we have 2 square root of 2 times another square root of 2 minus, when we plug in 0 we get 1. So this is 2 square root of 2. Well, 2 square root of 2 times square root of 2 is 4. Minus 2 square root of 2 is the final answer. This is the length of this curve. So for more videos, visit